So this is part 2 of the half-angle identities. This time we're going to use the tangent problems and the tangent formulas. Okay, if you look at the top of the sheet again, you have the formulas for all sine, cosine, and tangent. All right, we're using the tangent one, so it's 1 minus cosine x, and then 1 plus cosine x on the bottom. So we're going to start off the same way. We have our pi over 12. We have to multiply that by 2 to find out what the x value is in our formula, which is going to be pi over 6. Okay, so now we do the formula just like it says in the top. You got 1 minus cosine of pi over 6 and 1 plus cosine of pi over 6. All with a big square root and a plus or minus in it. Okay, now if you look at your unit circle, which again you should have available to you, all right, we just got to find what the cosine of pi over 6 is, and then it's going to be 1 minus root 3 over 2 divided by 1 plus root 3 over 2. The big square root and a plus or minus. Okay, now yesterday we talked about combining the fractions on the top of in our problem. All right, but now we have a fraction on the bottom and the top. So we're going to do the same kind of thing. We're going to get common denominators and then combine them. So you're going to get 2 minus root 3 over 2 and 2 plus root 3 over 2. All within a big square root with a plus or minus. Okay. So now what we've seen this a number of different times where we have complex fractions. We're going to multiply the denominator by its reciprocal. Okay. What will happen is all the stuff from the bottom will cancel, and the other thing that will cancel will be the 2's here. Now 2 minus root 3 and 2 plus root 3, we saw this with the sum and difference and tangent. They are not the same thing, so you cannot just cancel them out. They have to continue on in our math journey here. So we have 2 minus root 3 on the top and 2 plus root 3 on the bottom. Okay, with a big square root with a plus or minus in front. Okay, so now what we're going to do is just like we did with the sum and difference for tangent, we have to multiply by the conjugate. Okay, if you don't remember the conjugate it is the same terms on the bottom. We just flip the sign in between them. So we have 2 and root 3, but this time instead of plus, it's going to be minus. Again, I can't stress this enough. This has nothing to do with the numerator of our fraction. It has everything to do with the denominator. So 2 minus root 3. Okay, so we multiply this out. So 2 times 2 is 4. All right, 2 times negative root 3 is negative 2 root 3. Negative root 3 times positive 2 is going to be, again, negative 2 root 3. And then root 3 times negative root 3, so they're both negatives, going to give you positive 3. On the bottom, 2 times 2 is 4. All right, we have 2 times negative root 3 is negative 2 root 3. Root 3 times 2 is positive 2 root 3, which is what we wanted to because those two terms that we just put down will eventually cancel themselves out. And then positive root 3 times negative root 3 is going to mean negative 3. Okay, again, it still has a big square root with a plus or minus sign on it. Okay, I don't want to forget about that part. So now we combine the like terms that we do have. We have 4 plus 3 on the top, which gives us 7. Negative 2 root 3 minus 2 root 3 is going to be negative 4 root 3. All right, on the bottom of our fraction, these two terms are going to cancel out. That's what the conjugate did. It got rid of our square roots on the bottom of our fractions. And then 4 minus 3 is 1. And we have a big square root with a plus or minus on it. Okay, now, like we did with the previous problems for the sine and cosine yesterday, when we take the square root of the top and the bottom is a perfect square. If you take the square root of 1, you just get 1. So we're left with 7 minus 4 root 3 with a square root on it. The square root of 1 is 1. We don't need to write 1 on the bottom of our fraction. So we're good to go. And now what we have to do is figure out what the sign is for this. And sign, I mean it's positive or negative. So we go back to writing our unit circle. Okay. Pi over 6 is here. All right, which is 30 degrees. So this is pi over 6. Okay, pi over 12 is half of that, so it's like here, it's 15 degrees. All right, so we got to figure out what is tangent in the first quadrant. Okay, so tangent in the first quadrant is sine over cosine, which is y over x. And since both y and x are positive there, this is going to be a positive number. And there we go. We're done. Okay, now this is the reason I did tangent half angles separately from sine and cosine, because obviously there's a lot more involved in these than the other ones. All right. On to number 6. We have the half of, 3 pi over 8 is half of something else. So we're going to do 3 pi over 8. Find out what value we're going to use in our equations, our formulas. We're going to multiply by 2, which gives us 3 pi over 4. Okay, so again, we use the formula for tangent. All right, we have the tangent. We have 1 minus cosine of 3 pi over 4, and then 1 plus cosine of 3 pi over 4, with a big square root and a plus or minus. So again, we're just putting that value into our formula, and now we can simplify. Okay, so 3 pi over 4 for cosine is going to be 1 minus, so 3 pi over 4 for cosine, like as I was saying, is going to be negative root 2 over 2. On the bottom, 1 plus negative root 2 over 2. The big square root and a plus or minus. Okay, again, you can find out where 3 pi over 4 is on the unit circle, and then it's the x value of that point. Okay, so again, just like before, now that we're not dealing with root 3 over 2, we're dealing with root 2 over 2. But still the same rules apply. We have to combine these fractions. So we're going to combine the fractions with a common denominator of 2. So we'll have 2 plus root 2 over 2. Notice it's plus because a negative and a negative is a positive. And on the bottom here, we're going to have 2 minus root 2 over 2. Not forgetting about our big square root with a plus or minus in front of it. Okay, just like before, we have this complex fraction. We're going to multiply by its reciprocal to get it to the top of our fraction. Okay, all this stuff cancels, and then the 2's cancel. We're left with 2 plus root 2 divided by 2 minus root 2. All under a big square root with a plus or minus. Okay, again, you can't just cancel out the square root of 2's and the 2's. They have different signs. You'd have to cancel out the whole expression, and you can't do that in this case. Okay, so just like before, we're going to multiply by the conjugate. Oh, let's put that down here. So it's going to be 2 plus root 2. Excuse me. It's the same two numbers with a different sign in between them. There we go. Okay, if we multiply it out, 2 times 2 is 4. 2 times root 2 is 2 root 2. Root 2 times 2 is again 2 root 2. And root 2 times root 2 is root 4, which is just the square root of 4 is 2. On the bottom, 2 times 2 is 4. 2 times root 2 is positive 2 root 2. Negative root 2 times positive 2 is negative 2 root 2. And negative root 2 times positive root 2 is negative root 4, and the square root of 4 is just going to be negative 2. Okay. All right, so now we can combine our like terms. Oh, sorry, I forgot. Big square root with a big plus or minus. Now we can combine our like terms. 4 plus 2 is 6. 2 root 2 plus 2 root 2 is positive 4 root 2. On the bottom, these two cancel just like they're supposed to with the conjugate. And then 4 minus 2 is 2. But wait, there's more. You'll notice in this case, unlike the last problem, there's not a 1 in our denominator. So when you square root 2, it doesn't work out very nicely. However, you can see inside of our problem, let's change the color to highlight this, you have 6, you have 4, and you have 2. Okay, those are the ones that make a difference. And if all three of those numbers can be reduced by the same thing at the same time, you have to do it. All right, so let's go back to blue. All right, so 6 divided by 2 is 3. 4 divided by 2 is 2. The root 2 is still there. And now there's no denominator to worry about. And we do the big square root sign. And now we have to, again, figure out the sign of the problem. So we go back to the tangent here. We're doing 3 pi over 8, so we're looking at 3 pi over 4. So 3 pi over 4 is right here. Okay. 3 pi over 4 is 135. All right, if you do half of 135, you get like 72.5, I think, or something like that, which is going to end up being over here. Okay, yeah, let's find it exactly. It is. I don't want to do math in my head. So 135 divided by 2 gives you, 67.5. Sorry, my apologies. So we have 67.5. So that is, again, in quadrant 1. This is where 3 pi over 8 is. Okay, because 3 pi over 4 was on the other side. So that's half of 3 pi over 4 is 3 pi over 8. Okay, so again, we're looking for the sign of tangent in the first quadrant, which, like we saw in the first one, it is positive because both x and y are positive. So this is your answer. Okay, I know that's a lot of work. That's why we did this as a separate day. There's only 2 problems. Okay, so good luck with this, and we will see you soon.